talks like this is definitely a little more technical. And I know we're talking about Power BI, but most of what this talk about is actually data modeling in the context of Power BI, and how you need to make data form in order to be more performant and useful, shall we say. So if there are questions that come up throughout this, just interrupt me. I have no problem doing that. We'll go from there. Like Maria was saying beforehand, I'm a partner and lead architect over at Iteration Insights here. You had on the slide 9 years of experience. No, I am 10 years officially now, so this is excellent. I do a lot of teaching in this space. I was a teacher instructor up at the University of Calgary in their BI program for a number of years, although running a business and having children has put that one to the wayside a little bit. And then we're involved with SAIT, the Southern Alberta Institute of Technology, also has a fantastic business intelligence program. So we definitely do some teaching and growing over there as well. But this is a little bit more of who I actually am. I do a lot of rowing right now for the Calgary Rowing Club. I'm big mountain biking, and I've got kids that I like to toss around and play around in the snow a little bit. I've got a couple of sites and stuff. It's all in the in the document here in the presentation. I should be able to post that alongside our YouTube video or whatever we end up posting with this as well. So you'll have links to this stuff later on. I do have the Power BI model that I use in this talk on that GitHub account as well. So if folks want to use that, pull it down, do whatever you want with it. It really just connects to an Azure database and does analysis on the Wide World Importers database that I've slightly modified. But nothing that's material for analysis on this. So what are we going to talk about today? There's three main things that I find folks need to know when they're coming into Power BI, especially from a technical standpoint. There's lots of constraints and choices that were made when Power BI was implemented that have downstream implications for you. Anybody coming from the analytics world. So if folks are more used to building out AI ML models, or if you're building transactional systems with a SQL backend, all of those have very good reasons for having the data models that they do. But so does Power BI. And Power BI is definitely different than some of those other types of systems. So we're going to talk about what those constraints are and why that kind of pushes us into making some of the data architecture choices that we'll end up making. Now, normally when I give this talk, it does take about an hour, and I know I don't have exactly that time, so I may cut some of the visual technique portions at the end. There's one thing that I really want to go over that I'll make sure that we chat about, but for the purposes of this chat, we're going to concentrate on those two first points there. What are the constraints, and how does that influence our data architecture? So let's talk about that first. What is the underlying Power BI engine? And it was originally called the Vertipack engine. I think when it first came out in 2012, or at least in SQL Server 2012, it was called Denali as its code name. But it was used for three main things. And they found that when most business users were doing analytics, they were doing these three things. So the one was filtering large data sets. So we always want to think of when we're doing analytics, we're taking large or very large data sets, and we're filtering them down under different contexts to see what are our summations, what are counts, what are other types of aggregations that are happening on those data sets. So that's the second thing that actually tends to take place, is Aggregation. So how do we aggregate numbers together in order to make strategic business decisions? The last thing that we need to do on those data sets, and it kind of goes in conjunction with what I was saying before, is we want to capture and manipulate the context in which those calculations are performed. And I know that's a lot of words without a lot of meaning if you don't already know what's meant by the word context. And context is incredibly important regarding Power BI. So I'll go over that a little bit later, but just knowing that when we say context, I'm looking at, say, a specific number under specific filters, and those filters define really what the context is. Anyways, the VertiPack engine, like I said, came out in 2012. Actually, I think it came out a little bit earlier as part of the Power Pivot add-in to Excel, but it first came into the SQL Server world in 2012 as tabular models were first released. Power Pivot, the extension of that, which was Power BI, which had a bunch of other things like Power Maps and Power Query and a whole bunch of add-ins for Excel. Power BI itself, the standalone project, SQL Server Analysis Services, tabular mode, and then any of the Azure Analysis Services or Power BI Premium models also use the same underlying engine to perform these types of calculations. Big thing about it is that it is an in-memory columnar database. Now, Power BI can do pass queries to other data sources, things like SAP. You can do direct query to a SQL server. There are other sources that you can do these direct query where it's not using the in-memory columnar database. But in order for Power BI to be largely performant, where you have a lot more control over it, you want to use the in-memory columnar database. And with Microsoft Fabric coming out, they're also transitioning over to the direct lake mode, which really just means that all the data exists within the Fabric landscape, and all queries happen on a in-memory columnar format Parquet file, Delta Parquet files in there. But it's really important to understand what that actually means. What does that imply for our data? And what that is here is that a columnar database takes all of the columns that you have within a data set and breaks them out into their constituent columns. And what are some of the implications of doing that? Is the big one is that it allows you to do compression very, very quickly. That does compression in a couple of different ways. There's three ones that we're going to talk about here. But then it also allows us to do those other three operations that we want for analytics. One, filtering. Two, aggregating. And three, capturing and manipulating the context. So what does that what does the VertiPack engine do to compress data? First thing it does is it encodes data in a couple of different ways. So on the left-hand side, let me grab my laser pointer over here. So you can see we have value encoding. This is usually on numeric data and specifically on integer-based data. You can do it on fixed decimal places, but if you have a decimal format within a Power BI data set, this value encoding does not take place. Anyways, big one is that it does value encoding. On the left-hand side here, you can see we have numbers from 194 up to 216. If you were to represent those in a binary format, you would need 8 bits of data in order to encode that. What'll happen is it takes a unit value of 194. This is just the lowest value. So we take the range of possible values and we just subtract that from the unit price. And you can see that that 194 gets translated into this 0 amount over here. And then the largest value of 216 was translated into this 22 number. So a range of 22 numbers is significantly less than 216, means that we can compress this in 5 bits ultimately. Now, there's a whole bunch of other implications that you could take place. So if there's any C developers out there, you'll know there can be other challenges if you try and have a piece of data that's 5 bits wide, but that's kind of outside the talk right now. The point is that we have a smaller memory footprint. Smaller memory footprint means that there's smaller reads and smaller and quicker aggregations that that will ultimately take place within something like this. The next step of encoding that takes place is what's called dictionary encoding. This uses a hash map of where we say, okay, I have a color. In this case, I've got red, white, black, blue. Those get mapped to a single number, and there's only 4 values, which could be encoded in 2 bits. And then those 2 bits are what allows to look up the ultimate dictionary value of each of those bit encodings. So rather than storing the word red, white, black, and blue, we just store the numbers 0, 1, 2, 3, and then it is a lookup to a table. What's nice about something like this is that when we're actually trying to use this in the context of analytics, oftentimes what happens is I just want to filter this table, which passes over to this encoded ID column and allows me to say, okay, filter just down to the number 1s, or filter down to the number 3s, or maybe the number 2s and 3s. Whatever that filter ends up being, it allows me to do this very quickly, and then that gets passed down the line as well. So those are the 2 main things that happen with encoding of the data. The next thing that happens in order to compress our data is run length encoding. So oftentimes, because your Power BI is doing analytics on very large data sets, the big thing that happens is we have lots and lots of repeated values. So in this case, we say we're looking at a date dimension. So it's just a table of dates, 1 row per date. There could be a column in that date dimension that has quarters, and we're just going to have this number or this value encoded a number of times. It's going to be repeated over and over and over again. In this case, 310 times. I've got Q1, then I've got Q2, and then there's going to be a Q3 and Q4 eventually. But those are really just based off of the ordering that takes place. So Power BI does a bunch of stuff behind the curtains to say what's the most efficient ordering of our rows to make this performant. But what happens is I can take all this data and compress it into a very small table that just says, okay, I've got Q1, it starts at row 1 and goes for 310 rows, or Q2 and starts at 311 and goes for 290 rows, and so on and so forth. I could have this Q1 repeated down here if there are multiple instances, depending on the order of the ultimate table. But that's really how the run length encoding works. And if you put these things together, what'll end up happening is we've got Q1. So this whole column gets first dictionary encoded into this type of format. You can see there's only a couple of bits that are actually used to encode this. And then that gets stored really as the 2 relatively small tables of a dictionary for what the values that we're trying to look up are, and then what are the data rows actually representing. So I've got, the value 0, which is Q1, goes through 310, and then the value 1, 290. So we've got a very, very large memory footprint that gets compressed into a very small memory footprint very efficiently. So that's just really how data gets compressed. Now, there's another implication that happens in here that's outside of the underlying table compression, and that's how tables are linked together. In Power BI, they're linked using relationships. it's very, very important that you understand that these are only based off of a single key column within each of the relating tables. So you can see on the left-hand side there, I've got my sales table. I have a product key column that maps to my product table on its product key column. What happens behind the scenes, and you have no control over this, is that there is a relationship table that gets generated. And it says, okay, row one or product key one is related to product key one over here. Same thing with 2 and 3. And then I have product keys 4 and 5 in my sales table, but no related product in my product table. This is, referential integrity violations. And all Power BI does to handle this is it maps it to a blank row. Again, this blank row is not something you're going to see in the data when you go to look at a data set, but it's something that gets generated behind the scenes in order to preserve referential integrity. One thing that can be important about this is that sometimes not knowing that this blank row exists can cause referential integrity issues, or sorry, not referential, many-to-many relationship issues. Again, many relationships are useful, but they're more complex operation when it comes to doing data analysis, and especially context transferring between different tables. So the way Power BI ends up working is it's going to filter our product table down to a subset of its rows, and that subset navigates through the relationship table down here, gets us a subset of its rows, which then goes back to this product or the sales table on the product key, getting subset of its rows, and then we do our analytics from the sales side. So it is a complex operation that takes place when you do filtering. All of this is hidden behind the scenes. You don't have to worry about how that actually works. What's nice is that we get to utilize these benefits, but knowing about this allows us to make very performant models, and it also simplifies a lot of our DAX calculations. One of the big things is that Microsoft intended this to be made in what's called a dimensional model, and I'll talk about that a little bit after we're done talking about constraints. But if you use the models and you use the intended way that this was to be used, you're going to save yourself a world of difficulty when it comes to things like DAX calculations or aggregation definitions in the underlying model. So if we take all of these things together, what are some of the implications that we have? Well, one, the lower cardinality of a column, the more efficient queries on that column are going to be. Now, what do we mean by lower cardinality? All we really mean by that is that we have as few distinct values in that column as possible. Now, I will also say that this largely applies to dimension tables, but if you have value tables that you're aggregating as well, it can make those queries more efficient as well. The other one is that data duplication is largely not an issue when it comes to either space nor query performance. The only time that data duplication would make things challenging is if you're trying to have a transactional system where you need to do multiple updates or multiple reads and make sure that all the values are updated at the correct time. And that's why it's better to have a transactional system that's modeled completely separately from the analytical system. Let me just take a quick aside of what I mean by that data duplication. I'm just going to go to the actual model that I have for this talk, and we'll just quickly talk about this dim stock items table. So this is just a dimension table, and there's 227 rows in here. But what we mean by duplicated values is if you say look at this lead time days, you'll see that the value 14 is repeated over and over and over again. Actually, let's look at a different type of table that's more of a lookup. Here's a good one, color name. When you're modeling this within a transactional system, oftentimes you're going to have a table that is just the colors. So I have an ID column on that says ID 1, 2, 3, 4, 5. And then I'm going to have a color name column in that table that has red, white, black, blue, purple, whatever other colors you need in there. That is going to be very efficient from a transactional system, so that if I say, okay, ID number 1 was white, but I actually wanted to add another white color to this, so I'm going to change that one to cream. That's going to update all of my colors that were referred to the number 1 as being cream colored. It allows for consistency within the underlying data model. In a columnar database, if you wanted to update all of these, you would have to update each and every row that had the reference to, say, white. And that would be a lot more columns than just doing the one row in if the table was separately. However, when we do analytics, we're not doing inserts, updates, and deletes very often. We only do that at process time. So if we think about those two different types of tasks, we're just aggregating. So this allows me to filter, and it allows me to aggregate these types of things much quicker. Go back to here. Relationships being based off of a single column in two tables also means that you have to account for that within your models. So if you're modeling the data outside of Power BI, you do need to make sure that you have specific index columns and foreign keys on your tables that can refer to a single column. You can't say, okay, here's the business key, person 1, 2, 3, 4, 5, and they had an effective date from January 1st to June 1st, and then from June 2nd to whatever the current date is. So there's two rows that are for that person, but I have a single time span. I can query that relationship with something like SQL very efficiently, but in Power BI, I need to make sure that there's a single value that makes that reference work. And the last thing I'm going to talk about is traversing relationships. This can mean that if you have multiple relationships that you need to chain together in order to do the analytics that you're looking at, that can be a very expensive operation. I want to illustrate that with a bit of a diagram on what's called a snowflake dimension. Now, this is from the Power BI documentation. The link is at the bottom there. So if you go and search Power BI star schema, you'll end up seeing this picture. But the thing I want to talk about is what happens when you have this type of model in Power BI. Big one is that if I go and look at a specific category, what's the underlying engine going to do? So I want to filter this down to one value. Why won't this draw for me? All right, there's my pen. There we go. I want one value out of here. So what'll happen is I've got this one value, which then goes to the underlying relationship table that has, there's one value in there, but there could be many values in the product subcategory table. So that's going to give me many values in here, which then needs to transition over to the relationship between the subcategory and the product table, which is going to give me many, many more values in here, which then I need to filter this table to, and that's going to transition over to this relationship. So I'm going to have lots and lots of values in here, which is going to filter down to lots and lots of values over here. This causes a cascading effect which will slow down your queries. So unless you need to have a snowflake dimension, and there are reasons to do that, especially if you have multiple fact tables at different granularities, it's a much better practice to denormalize your dimensions onto a single table than to have them broken out as separate tables. So all we mean is that we take whatever the product category is, put that on the product subcategory table, and take both of those columns and put that on the product table. So it ultimately just would get rid of two of those tables, and then I just need to traverse a single relationship to do the analytics that I'm interested in. All right. Just a couple of things about data architecture. There are so many different types of data models out there that are very, very useful for the specific purposes that they have. The first one is going to be one big table. This is the traditional non-technical person's implementation of analytics, and usually that takes place within Excel. But these are for folks that haven't necessarily had formal training on doing data analytics, or don't necessarily know a better way to do it, and they just need to get their job done, so they do whatever tasks are necessary to actually do that. So they'll pick one big table, call it data, add some VLOOKUPs to other tables to get the various values that they want, slap a pivot table on top of that, and then do their aggregations. That works perfectly fine, but it can have lots of limitations, particularly the size limitations of an Excel file. It can greatly slow down your models, or greatly slow down analytics when you need to, say, do data refreshes or something like that. And there are other problems when you just do that in a from a non-technical standpoint. Now, I will also say there are a number of analytical tools out there that absolutely need one big table. I know Tableau is really useful when you have one big table. It's really efficient to do that type of filtering and aggregating that we're doing in Power BI as well. Oftentimes, though, it expects that one big table. Also, AI and ML is generally done on when you have one row per observation. So you're going to have these tables that have thousands upon thousands of columns, and it'll work perfectly fine for that purpose, but it does greatly slow down your model in Power BI if you use that. There's also some other implications, like having multiple facts or multiple things that exist at different granularities. For example, if I had all of my transactions that I'm trying to aggregate, and maybe I had a budget, that budget's probably not going to be kept at the same granularity that my transactions are kept at. And if you separate them, how do I join these tables? What if I have multiple facts, or many different measures that we're trying to create that are all kept at different granularities? Whole bunch of implications for doing that type of thing. Anyways, we also have normal models. These are the third normal form, fourth normal form, the Boyce Codd, which is kind of the 3.5 normal form. These are when you're trying to model data for transactional systems. So most ERPs, most CRM type applications are modeled using these types of techniques. Third normal form, fourth, fifth normal form. Depends on the types of relationships that exist within those databases. Again, like I said, this reduces data duplication. It's very efficient for doing inserts, updates, and reads, all your traditional CRUD operations. But it makes for lots of joins. It makes for lots of relationships between tables, and it will be very inefficient for doing large-scale filtering and aggregating. So may not be suitable for Power BI. we have the Inman Corporate Information Factory. This is, going back 25 years, maybe almost 30 years at this point, where we took data mart, the data mart idea, and then we got rid of duplication and made the underlying data stores significantly more efficient as well. This is a good practice in some data warehousing, but again, because of Power BI, like I was saying, with having lots of relationships, that can greatly slow down how Power BI functions. And then Data Vault, I will very briefly talk about. Not a lot of folks within North America use Data Vault anymore. It was a data model that came out late 90s, early 2000s kind of thing, that was used for storing large amounts of data very quickly that you can integrate new data sources into the data model in a very efficient way. So it does have its place, but again, it's got lots of relationships, lots of lookups, and it's not going to it's not going to aggregate data very quickly because of that. So the last one we'll talk about is Kimball dimensional modeling. I have the data warehousing toolkit over here that I still have on my desk and reference regularly. And the reason is because this is the type of modeling that Power BI expects your data models to be in. And don't take my word for it. This is directly from the Power BI documentation, and it says down there that the Data Warehouse Toolkit is really what this was designed for. So again, the links there. That's actually a really good article to read and be familiar with. But for folks that are just coming to the analytics world or at least to the Power BI world, how do we actually do this type of modeling? And it's really broken down into two main ideas. And what it is that data gets divided into two different categories. Data either measures a specific event. These are what are called fact tables or facts, and data that describes that event. So the who, what, when, where of a specific event. So if somebody makes a purchase, who's the customer who made that purchase? That's going to be a dimension. When did they do that? So the date or the time are going to be different dimensions. What did they buy? The product is going to be a type of dimension. Where did they buy it? Location is going to be a dimension. These are very, very common types of ways of describing business events. And then there's also an idea of bridge tables, but that's a little bit outside the scope of what we want to talk about today. There's going to be many-to-many relationships that exist. If you're interested in those, go read that documentation that I talked about a little bit before. They do a pretty good job of talking about the implications of when you have more complex relationships like that. So how are these things related together? It's very basic in all honesty. We take our dimensions, they go around the outside of a fact, and then we have columns within each table that allows to refer to the other table. So our fact table refers to our dimension tables in various ways. And like I said, with Power BI, you need to have a single column that actually defines that relationship in order for for Power BI to be efficient and make things work correctly under the hood without any additional DAX calculations or custom aggregations. There's a pretty well-known 4-step process for doing this, and all it is we want to select the grain, we want to select a specific business process. So just decide what I want to do analytics on. 2, I need to declare the grain. So what's the maximum level of detail that I can capture around that business process? I need to identify the dimensions that take place, or what are the ways I can describe that specific business process? And then 4, I need to identify the facts and measurements. So are there multiple events that make up that business process? Do I need to capture multiple things? Like, is there an order quantity and a purchase price? And then I would calculate the sale price of that specific item. I can add multiple different ways of aggregating data up in order to get this to function. So that's largely how you do the design process. And it's fairly simple to do. But if you do this over and over again, what you're going to find is that there's lots of reuse that you can utilize in more and more data models. So let's just take a very brief example from supply chain because there's actually a pretty good sample data model that Microsoft has built and provided. I think they built this in 2016, 2014, something like that. And it's the Wide World Importers database. It's really good for actually generating data as well. And what it does is it has a single entity in the middle. This is represents, us as a business, or if somebody is learning how to build these types of artifacts out, it represents us as an entity. And then we have downstream customers. So who are the people that we're actually serving? And we serve them products. Well, how do I get products? That's my upstream vendors. So you're going to see that we have we have products that are flowing from our vendors to us, to our customers. And this could be a very useful business process. Each one of these can be their own distinct business process because I may be able to order products at a different price than I'm going to sell them at. And you have to do that in order to be a business. Otherwise, you're not going to be very profitable. The other thing we have to manage are the actual requests. So a customer requests for me to have products. I request my vendors for products. Those aren't going to take place necessarily at the same time that I actually deliver the product, either to me from my vendor or to my customer from me. And then on the other side, we also have financial transactions. So where's the money actually going? Money's going from my customers to me, and then I need to pay my vendors for the products they sent me as well. So this is a pretty standard example when it comes to supply chain. And you can see that there's 6 different business processes that are taking place just within this very simple model. So we're going to just take a single request or a single process in here and model it for analytics. Now, the underlying database in Wide World Importers has a lot of different tables with lots of different relationships that make up the underlying model. There's purchase orders, there's purchase order lines. Those are associated with various stock items and different suppliers, and those suppliers have different categories, and suppliers live in different cities, and all of it's related to a bunch of different people in different ways for who made the sale or who took the sale, because we've abstracted a person out within the underlying database. Like I said, there's a lot of complexity within this type of system. But this type of model is largely useful within a transactional system, not a analytic system. What I would do is take this type of model and model this using the 4-step design process. So let's take that. We're modeling this as I just want to understand my purchase orders. What's the granularity that I'm going to capture? Well, I want 1 row per purchase order line. What are the ways I can describe each of those purchase order lines? I have dates. Any business process is going to be associated with a date or a time dimension, because in order for an event to take place, it has to take place at a time. So you're always going to have a date or a time dimension in these types of models. But we have a what, the stock items or the products that we're modeling. And then we have the who. Who are we purchasing from? My suppliers or my vendors? What are the ways that we are actually going to measure this business process? Well, it's the number of products we ordered, the expected cost when we receive the items. So there can be more. This is not a all-encompassing example, but this one is very useful for it. So in order to model this in Power BI, it's really simple. I have a couple of different dimensions: my order date, my expected delivery date. I've got suppliers, I've got stock items, 4 different tables. And then I've got a central fact table that stores all the values that I'm using to measure this. I can count my orders, I can get my expected costs, and I can talk about how many products I've actually received. So that's basically it when it comes to visualizations, or sorry, data models. My next slide's got visualizations. I really just want to talk about one thing when it comes to visual techniques, because I find folks that are coming from a more technical background don't tend to have a lot of experience when it comes to say developing a report. So if you have business users that are coming to a DBA for reports, this is a really easy framework for you guys to use. 10, 15 years ago, a gentleman by the name of Wayne Eckerson from TDWI came up with an idea called the MAD framework. And I think the framework is good. There are a couple of ideas in there that I don't necessarily agree with that I'll talk about in a second. But what it really did is it talked about how do we divide our reports into a couple of different areas so that they make sense for our end users. What it is I need a layer to monitor what's going on, so what's taking place either right now or in the near past, like what happened yesterday. I need to analyze my data, so what are some trends or different categories or other types of aggregations that take place. And then I need to look at the details. I need to be able to see what has taken place on an individual transactions. Now, when he originally built this framework out, he said, oh, the executives are only interested in the monitor layer, and middle management needs to do analysis, and then the detail layer is for our analysts. I don't agree with that idea, because I find that every level of our stakeholders is going to be interested in most of these layers, but they're going to use it for different purposes. So I always find the purpose is a better way of taking this as a framework. And what it would do is say the monitor is just say, what is current? What is going on right now so that I can look at my data sets and make sense of it? And then the analyze is talking about what has happened in the past. Where are my trends? What are my categories? And what has actually taken place? And lastly, the detail layer is really just so that my end users trust what I've done and that I've done it correctly. It's the prove it to me. Because if I can't drill down into a specific transaction and know that it's the same as what my ERP says, I'm not generally going to believe your data model. So I always find that this is a good framework for building out these types of models. I've got a couple more slides, but I'm not actually going to do them because, like I said, I want to be cognizant of folks' time. But I do want to show how I structure a Power BI report so it's useful in that MAD framework standpoint. Now, what I've got here, let me just make that a little bit smaller. We'll just make that as big as possible for you guys. I usually take whatever business process I'm interested in and I build 4 pages. You can see I've got all these different pages down at the bottom. One talks about the recent, what has taken place since I refreshed the data last, because my data set only goes back, it only refreshes once a day, and it even does data once the prior day. So you can see this includes today and yesterday. This just gets me the data that is most recent in my data set. And I get some information in here. I've got, what are my expected costs? What's my month-to-date costs? What are my total year-to-date costs? Maybe these things I need to know right away as I'm looking at a data set like this. I've got very basic categorization, maybe some mapping capabilities. And then I've got the individual details over here, and I'll get to that in a second here. But this is what I would say is my monitor layer. I'm also going to have a page that is about analysis. Now, this allows me to do some trending. And if I just change this over here, you can see I can see what how are purchases taking place over time? How is it comparing to the prior year? How many orders have I had? Where are those taking place? Maybe some other categorization. Not, like I said, this is not the end-all be-all of this type of modeling, but this is a relatively good framework to start with. But what this allows me to do is I can say, okay, what's going on in January 2023? Why are my costs so much higher? And I can get to this. I can drill down into that specific month, and I can say, oh, something's going on in here. Maybe something has taken place on January 13th that I need to actually get some insights into. What you do is you set up drill throughs so that you can say drill into January 13th as a specific day. So what you're going to see here, this is an almost exact copy of my recent purchase orders, but this filtered over at the top left is the specific date that I'm interested in, rather than a day that's always crawling forward. So always structured. I always structure these two tables in that way. And then lastly, we've got a table of the purchase orders itself. So if I'm interested in a specific purchase order, I have the ability to go see that. And the way you use this is that from each of these purchase order tables, I've got a table over on the right-hand side here that says, oh, here's my purchase order 9259. I'm interested in that one. I can drill through and get the details of that specific purchase order. It allows me to drill through. I can see what are the costs that are associated with that, what are the total items that are ordered. And it allows me to make sure that, okay, the numbers that I'm seeing on here match what numbers I'm seeing on my other tables, and I can get specifically to them. So you can see I've only got 42 products actually ordered on here, and that's how that ends up taking place. Anyways, and I can get that same kind of detail from a different table over here for my my recent ones as well. Or I think I made one change while I was talking with somebody about web links, and there we go. Okay. Now I've just got the actual 3 rows that I was interested in. But yeah, that's how I structure tables or reports so that I can have something delivered very quickly. You can see this report looks largely professional. I think it took me maybe 15-20 minutes to actually put the report together because I've done this type of thing before, and because I have a framework to do, it allows me to get data in the hands of its stakeholders for whatever they need it for very quickly. So those are my recommendations for you folks. The slide that we'll end up posting, I think there's some stuff about color theory in here. I'm not going to go over why you would use those or all that kind of stuff. All that stuff's online, and then some resources for doing that. But the last one I do want to just refer to is if you guys ever need some information about what visualization to use and when. We've actually developed a really good blog article and Power BI report. Deanna Arciniega and one of our other consultants, Eric, ended up putting this together probably a year ago now, maybe a little more, and they talk about what visualizations do you want to use and when. So for example, if I've got a line chart, what does it look like? When do I want to use it? Why am I using it? What are the use cases for it? So I will leave that to you guys to peruse if you're so interested in, but it's a pretty good article. All right, that is all I've got.